So section 2-2 talks about solving inequalities by adding or subtracting. So we're just doing one-step inequalities, so it should go pretty quickly. And we talked in section 2-1 about open and closed circles. Sorry, I have a cold. So let's solve this inequality by getting x by itself. So that means we need to get rid of the positive 9 by subtracting 9 from both sides. That gives us an x on the left, less than sign, and then 6. So x is less than 6. We're going to graph that. So the solution would be any values for x that would be less than 6 but not including 6. So at our boundary point, which is 6, we'll have an open circle because there's no equals to. And then this inequality sign looks like an arrow pointing to the left, and less than is to the left, so we're going to draw an arrow to the left. And that's it. It's that easy. Next question. So for example 2, draw your line. We want to get d by itself. So to get rid of minus 3, we're going to add 3 to both sides. The 3's cancel, and you have d is less than a negative 6 and a positive 3 is a negative 3. So our solution would be any value that is less than negative 3 but not including it. So at our boundary point of negative 3, we will have an open circle because it is not equals to. This looks like an arrow pointing to the left, so we're going to draw an arrow to the left. Done. For example 3, don't let the decimals bother you. So we're still going to solve it same as we have been. Draw your line. Focus on your variable. So we want to get n by itself. So to get rid of minus 4/10, we will add 4/10 to both sides. Add, well, let's fix that. When you add and subtract decimals, you want to line up the decimal points. So on the left, 7 plus 4 is 11. Carry the 1. Bring down the decimal point. And add down. So you get 1.1 is greater than or equal to n. The problem with this one is our variable is on the right. In order to graph it for inequalities, we have to have the variable on the left side. So we're going to switch the left and the right side. We're going to play what I call Vanna White. We're going to switch the left with the right side. And when we switch the left with the right side, we also have to flip this inequality sign because technically read backwards, n is less than or equal to 1.1, whereas 1.1 is greater than or equal to n. So I want the n to read less than or equal to. So this is our true solution. So unfortunately, they've given you the graph for you down here. With a decimal, I probably would have partitioned my graph into tenths. It's much easier to graph, but they didn't do that for you. So we're going to put 1.1 right about here. And so that value there is 1.1. We are going to have a closed circle at 1.1. And then this inequality sign is an arrow. It looks like an arrow pointing to the left. So we're going to draw an arrow to the left. And we're just going to check it real quick to prove to you that flipping the inequality sign was the correct thing to do. So my favorite checkpoint is always 0. So plug 0 in here. 0 minus 4/10 gives you a negative 4/10. So if we're checking it, our left side is still 7/10. We want to know, is that greater than or equal to 0 minus 4/10, which is a negative 4/10. Is that a true or false statement? Positives are always greater than negatives, so this is a true statement. So since it's a true statement, I'm going to put T here for true, the arrow should be going in the direction of the 0, which it is. If we hadn't flipped the inequality sign, you would have drawn the arrow in that direction, and that would be incorrect. Last problem is a word problem. It says the memory in Tania's camera phone allows her to take up to 20 pictures. It's such a shame. Most of you would die if you only had 20 pictures. Tania has already taken 16 pictures. Write, solve, and graph an inequality to show how many more pictures Tania could take. So before we can write our inequality, we need to define our unknown. So we're going to let x equal, well, what is it that we don't know? How many more pictures Tania could take. So we're going to let x equal number of pictures. So if she can have no more than or take up to 20 pictures, that means she can't go over the 20 pictures. So her total number of pictures has to be less than or equal to 20. So we've got less than or equal to 20 pictures. She's already taken 16. We're going to add to that however many more pictures it takes to get to less than or equal to 20. So that's our inequality. You don't want to set up your inequality with x by itself. Then you went ahead and did the solution. So to solve this, we're going to get x by itself by subtracting 16 from both sides. And you end up with x less than or equal to 4. So that means Tania could take 1, 2, 3, or 4 more pictures. So to graph that, the boundary point is 4, so we'll put that in the middle. So there is going to be a closed circle at 4 because she can take 4 pictures. Technically we really can't put an arrow here because we can't take 2.5 pictures or 3.2 pictures. We can only take pictures in whole number increments. So she could take 4 pictures, she could take 3 pictures, 2 pictures, 1 picture, and technically she could take 0 more pictures and still stay underneath her total number of 20 pictures. So this is kind of a weird graph, but in a word problem situation, a real life situation, that's what it would look like. You can't take a partial picture. And that's it.